Hi, my name's Enzo.
And I'm Scott, and this is the chain rule. So hopefully you have some background on derivatives. The chain rule is basically how we're going to derive composite functions.
So, as Scott said, you need to know your power rule, and we use the analogy of a plain M&M to explain the chain rule. So if you put a plain M&M in your mouth, first you taste the shell, and then you taste the chocolate, and similarly, that's how you would derive a composite function.
So you might be a little confused, but let's show you how it looks like when you do the math. So basically we have your y equals f of g of x. That's going to be your composite function. In this case, the f is going to be your shell, your g of x will be your chocolate. So when you derive the chain rule, you follow this rule. So your derivative of y will be the derivative of the shell, you keep the chocolate, times your derivative of the chocolate. So in this case, it shows y prime equals f prime of g of x times g prime of x.
So let's put that into practice and go to an example. So in this example, y is equal to 4x minus 1 squared. The first thing you want to do is identify your shell and your chocolate. Usually your shell is going to be an exponent, so we can identify the squared as the shell and the inside as the chocolate. So we do a normal power rule. We bring the power down and then subtract the power by 1, so we have a coefficient of 2 in front, and then we multiply by the stuffed prime in the middle, which is the chocolate. So we're left with y prime is equal to 8 times 4x minus 1.
Now let's look at a little harder problem. In this case, you're using trigonometry. So we have your y equals sine of 3 of x. So identify your shell and your chocolate. In this case, your shell, your outer function, will be the sine. Your chocolate, your inner function, is the 3x. So first, just as we said, you're going to derive the shell. So in this case, you're going to have y prime equals cosine, keep your chocolate, 3 of x. Now you're going to multiply it by the derivative of your inside, which is your chocolate. So you have y prime equals cosine 3 of x times 3, the derivative of 3x, and you're left with y prime equals 3 cosine 3x. And that's how you derive a plain M&M. We did it. We made it through the first composite function.
Now we're going to learn how to derive a double composite.
So in this case, we like to use an analogy of the peanut M&M because it's a little more complex. So if you can visualize it or if you have M&Ms, it might help. So in this case, we have 3 layers. Your outer layer is the shell, followed by the chocolate, and lastly the peanut. Now this is how we're going to use in order to derive using the chain rule.
So just like Scott said, we have a new function, y is equal to f of g of x, and we're going to identify the layers first. We have our shell, which is the f function, chocolate, which is our g, and peanut, which is our h. So similarly to the last one, the plain M&M, we're going to derive it the same way. Our y prime is going to be f prime of g of h of x, so we keep the middle intact. Then we derive the chocolate, which is our g prime, and we keep the h of x intact, which is our peanut. And then finally we derive our peanut.
So now let's look at an example and simplify all of this. So in this case, we're going to have our y equals cosine cubed of 3x squared plus 5x. So let's start by identifying your layers. First, you're going to have your shell. In this case, it's going to be the cubed. Then you're going to have your chocolate, which is going to be the cosine. And lastly, your peanut is going to be the 3x squared plus 5x. So we're deriving using it the method that Enzo just showed you. This is how it's going to be derived. So you have y prime equals 3 cosine squared. So using power rule, we derived our shell. You keep the cosine and you keep the 3x squared plus 5x. Then you move on to the chocolate. When you derive the chocolate, you have negative sine of 3x squared plus 5x. Derive the chocolate, keep the peanut. Lastly, we're going to be deriving the peanut. In this case, it's going to be this function, so you're going to be left with 6x plus 5. Now when you clean it all up and put it all together, your last y prime will be equal to negative 3 cosine squared of 3x squared plus 5x, sine of 3x squared plus 5x, multiplied by 6x plus 5.
So for those of you that want a little harder problem, we call this a gobstopper because there's more than 3 layers. We're actually going to have 4 layers in this problem, and it goes as follows. There's y prime is equal to tangent squared ln of 3x squared. So we're going to identify our first layer, which is almost always your power, so we have the squared. Our second layer would be the tangent, our third layer would be the natural log, and our fourth layer would be the 3x squared. So when we derive this mess, we're going to have a y prime of 2, which is our power, we brought it down using power rule, 2 tangent, and we keep the middle, natural log of 3x squared, times secant squared, which is the derivative of tangent. Don't get confused about this squared, because secant squared is the derivative. We're not including the squared we had before. And then we keep the middle of the natural log of 3x squared, followed by the derivative of an ln, which is stuff prime over stuff. The 6x being our stuff prime and our stuff being the 3x squared. Then when you clean it all up, we're left with a y prime of 4 over x tangent ln of 3x squared times secant squared of ln of 3x squared.
And that's the chain rule.